What is gravitational force? This is the last lesson of chapter 16 and the last one in the book. Let's jump into it. So far, we've looked at how forces affect us. Let's do a quick review. What two things are needed to measure velocity? Speed and direction. Got it. How do forces interact? What's a synonym for equilibrium? How about equal? Two things that are equal. And today, we're going to take a look at what gravitational force is. So let's get started. We'll start by just thinking about a little bit of background knowledge here. Draw an image or write a phrase or scenario that shows what you know about gravity. Gravitational force, the force that acts between any two masses in the universe and pulls them toward each other. It's measured in newtons. You can see an image here with gravitational force. Some of you included it in your Freyer vocabulary yesterday. A ball is thrown in the air, and it comes back to the surface due to Earth's gravity pulling it back down. Weight is the measurement of the force of gravity on an object. It's measured in pounds or grams on the Earth. So here you can see that a person's weight can change based on where he or she is in the universe. The first image shows you a person on planet Earth who weighs 110 pounds. And then the other one shows you a person on Mars who weighs 42 pounds. But notice that the mass stays the same. It's 50 kilograms in both places because mass is the amount of matter in an object and it doesn't change. But weight changes because different objects, different planets have a different amount of mass and thus a different gravitational pull. Think on it. Why would the same apple in this picture be lighter on the moon? Go ahead and type your answer. And the real answer is because the moon is a smaller object. It has less mass, so it has less gravitational pull than does the Earth. Mass versus weight. Mass is how much matter an object contains. It's a constant for a body and does not change with location. The kilogram is a unit of mass. Weight is the force exerted on a mass by gravity. Weight is not a constant. It changes from place to place. The Newton is a unit of weight. So technically the pound is a unit of weight, but not mass. Think on it. What would happen if we didn't have gravitational force here on Earth? Go ahead and type your answer down below. One of the things that might happen if we didn't have gravitational force on Earth is that we might float away because we aren't drawn to the Earth. So we wouldn't stay put when we're standing. And we might also lose a bunch of muscle mass because we don't have to exert as much force to get ourselves up off the ground. There are other potential answers here. Take a minute and watch this video below the video that you are currently watching, and when you're done watching this video, come back and watch the one that you're watching right now. Force versus gravity. Force is a push or pull. It can be applied to change the direction of something. Gravitational force pulls on an object. Take a look at this video. The pitcher uses force to throw the ball. Jim Edmonds uses force to change the direction of the ball, hitting it away from himself. As the ball flies further away, gravitational force starts to take over to pull the ball back to the ground. When you're done watching the video, you can come back and watch the one that you're watching right now. Did you know all masses attract one another? Gravitational strength. The strength of gravitational force depends on two factors: masses of the two objects and the distance between their centers. Gravitational strength. Our planets orbit around the sun because the sun's mass is larger than any other planet. The sun is so far from us compared to the center of the Earth that the gravitational force of the Earth is the only one that we notice. But wait, if the sun's gravitational force pulls Earth and the other planets towards it, why don't the planets crash into the sun? That's all thanks to a magical phenomenon called inertia. Think on it. How are the terms gravitational force and weight related? Type your answer here. One potential answer is that gravitational force is responsible for weight to a certain extent, because an object has a mass or an amount of matter that makes it up. Like, let's be more concrete here. Let's say you have a water bottle on your desk. That water bottle has a certain amount of matter making it up. But remember, its weight can change based on where it is. Its mass won't change. So gravity is what gives that object weight, because without gravity, it just has a mass. But when we add gravity, pulling down on that mass, attracting that mass to itself, well, then that object has a weight. Think on it. Explain why objects weigh less on the moon than they do on Earth. Type your answer here. Objects weigh less on the moon than on Earth because the Earth is bigger than the moon. It's more massive, so it has more gravitational pull than does the moon, because the moon is less massive and thus has less gravitational pull. The smaller an object, the less gravity it has. The more massive an object, the more gravity it has. Inertia. The gravitational force of the sun combined with the inertia of the planets cause them to move in a curved path around each other, as you can see illustrated in the picture in front of you. Pause this video and watch the video in front of you. I'm sure you'll enjoy seeing how gravity has affected all the people here.